Greetings and welcome to online lecture 2 on unit number 4, that is ventilation and infiltration. This lecture we will discuss the second concept of unit number 4, that is indoor air quality and outdoor design conditions. And these are the contents of this lecture. Initially we'll discuss indoor air quality, which mainly depends on the air contaminants. 7 types of air contaminants we are going to discuss. Then the strategy to improve air quality, that is to remove these air contaminants or dilute these air contaminants. And outdoor design conditions, what are the requirements of outdoor air for the occupants, then usage of outdoor weather data and design, and outdoor weather characteristics and their influences. Uh, these are the various sources of air pollution in the house, like chemical fumes from the paint and solvents, then particulate matter, the carbon monoxide and other gases from cooking foods, some animal hair and dander, like paints. So the chemicals from the cleaning products also, some pollutants are generated. So the chemical release from the modern buildings and furnishing materials, then outdoor air pollutants come inside the house, mold or bacteria because of the wet wall, cigarette or smoke, then combustion gases from fireplaces and wood burning stoves, then fumes from attached garage, including carbon monoxide, and the gases including random uh, seeping through the foundation areas as well. So these are the various sources, houses available, which creates a pollution. So one by one, we'll discuss these various contaminants. So the first contaminant is total particulate concentration, and this concentration mainly comprises particle of building material, and the allowable indoor concentration of particle of 10 micron and less in diameter. Uh, so which generally escape from the filter. So above 10 microns, the filter can be trapped, but below that, it escape from the filter also, and it comes into the room. So which mainly causes uh, penetrate deeply into the lung. So these are the micron size, 5 micron and 10 micron. The second is formaldehyde and organic gases. Formaldehyde is a colorless, pungent smelling gas. It comes from pressed wood product, building materials, and combustion. Formaldehyde causes eye, nose, and throat irritation, as well as coughing, fatigue, and allergic reactions. Formaldehyde may also cause cancer. Other organic gases from the building materials, carpet and furnishing and cleaning materials like this. So mainly the source of this formaldehyde and organic gases, that is from wooden material, that is especially wooden furnitures, as well as the some building materials. So this is second one. And we have also discussed the various causes of these gases. It mainly affects on eye, nose, and throat, and also it is allergic. Sometimes it may cause cancer. So this is second harmful gas. Random is a third type of contaminant. Is a colorless and odorless gas, and is released by a decay of uranium from oil soils. So it released from the oil soils like this, and rock beneath the building, well water, and building materials. Randon and its decay products travel through the pores through the soil and rock like this, rock and infiltrate into the buildings along the cracks and other openings in the basement slab and walls. Randon at high levels causes lung cancer. So such kind of it mainly escape from the foundations, especially beneath the, and it creates a lung cancer as well. The fourth biologicals, that is, these include bacteria, fungus, mold, and mildew viruses and pollen. They may come from wet and moist wall like this. This is a moist wall. So generally it comes from moist wall, carpet, furnishing, and poorly maintained dirty air conditioning systems, and may be transmitted by people. Some biological contaminants causes allergic reactions, and some transmit infectious disease. Combustion products, this includes the environmental tobacco smoke, nitrogen dioxide, and carbon monoxide. Environmental tobacco smoke from cigarette is a discomfort factor to other persons who do not smoke, especially children. Nicotine and other tobacco smoke components cause lung cancer, heart disease, and many other diseases. Uh, Nitrogen dioxide and carbon dioxide are both combustion products from unvented kerosene and gas space heater like this, uh, food stores and fireplaces. Nitrogen dioxide causes eye, nose, and throat irritation. It may impair lung function and increases respiratory infections. Carbon monoxide causes fatigue at low concentration, impaired vision, headache, and confusion at higher concentrations, and is fatal at very high concentration. Houses without gas heaters and gas stoves may have CO levels varying from zero point 0.5 to 5 parts per million ppm. So most of the fireplaces, it come these combustion gases like nitrogen oxide and carbon monoxide releases. Human bioeffluents, this includes the emission from breath, including carbon dioxide, exhaled from the lungs, body odor from sweating, and gases emitted from flatus. So these are the 7 air contaminants present, and a one-step solution to this indoor air quality in some modern buildings. So biopure air active living walls uh, uh, can be developed. It is the most powerful and effective air cleaning systems in the world, and is naturally the best way to clean up uh, polluted airs. So these are not a normal trees or leaves, because it absorbs carbon monoxide, carbon dioxides, and it creates fresh air. Generally, it automatically pures the air and absorb the pollutants as well. So this is one of the most effective air cleaning system. It's obviously it's a natural. Uh, Naturally, this is the best way of clean up polluted air. So strategies to improve indoor air qualities. There are 3 basic means of reducing the concentration of indoor air contaminants and improving indoor air quality. Mainly eliminate or reduce the source of air pollution, then enhance the efficiency of air filters. So if some pollutants are not trapped in the air filters, then enhance its quality. So high quality HEPA filters can be used. Then increase the ventilation air intake. So by increasing the ventilated air, we can dilute the air pollutants. So these are the 3 basic ways, but dilution of concentration of indoor contaminants by outdoor ventilation air is often the simple and cheapest way to improve indoor air quality. The amount of outdoor air required for metabolic oxidation is rather small. So in addition to that, if more amount of ventilated air is used, generally we can overcome this difficulty, or we can dilute this indoor air contaminants, or uh, purity of the indoor air quality can be improved. This is the most simplest and cheapest way. That's why most of the hospitals, this solution is used. So maximum amount of fresh air is utilized. If you see the distribution of fresh air and written, almost 40% fresh air is utilized there. And some hospitals in operation theaters, almost 100% fresh air can be used. So these are the strategies to improve indoor air qualities, either to reduce the source, improve the efficiency of the filtration, or increase the ventilation. And these are the 3 strategies you can have. Then a requirement of outdoor air requirements for occupants. So mainly outdoor air is required for both comfort and process air conditioning systems. Outdoor air is required to do the following: to meet metabolic requirements of the occupants, that is the basic requirement of outdoor air. Then to dilute the indoor air contaminants, odor, and pollutants to maintain an acceptable indoor air quality. To support any combustion process or replace the amount of exhaust air required in laboratories, manufacturing processes, or restrooms. To provide makeup for the amount of exfiltrated air required when positive pressure is to be maintained in the conditioned space. So especially for positive pressure, for maintaining positive pressure, more amount of outdoor air is required. So there, uh, uh, in special cases, uh, the quantity required is more, other than the above four basic requirements. So these are the requirements of outdoor air, but the uh, outdoor air utilization is generally required for uh, estimating the transmission load, transmission heat load. That we will discuss in fifth unit. So that data is very much essential. So during the design of air conditioning system, the following parameters are often adopted. Even deciding the indoor and outdoor design conditions, outdoor data is required. So it varies from place to place or also region to region. Generally, it is required to calculate the space, cooling load, and heating load calculations. Summer outdoor uh, dry bulb temperature, coincident wet bulb temperatures are necessary to evaluate the coil load. So, depending upon the outdoor conditions, if the outdoor condition is humid, the load on the coil is more. If it is dry, the load, especially latent load, is less. So also to evaluate the coil load, the ventilation on the coil load, the ventilation load is and infiltration load is the major load. So outdoor condition affects on that particular load. So even the same capacity coil, its capacity is different in different climate. So that is where it is helpful. Thirdly, the summer outdoor wet bulb temperature is used to determine the capacity of evaporative coolers. So generally, the evaporative coolers, the decision is taken based on the outdoor conditions, especially wet bulb condition. The effectiveness of cooling tower or evaporative coolers are mainly uh, uh, dependent on the wet bulb temperature of the outdoor air. Outdoor weather data presented consequently for a whole year of 8760 hours or other simplified form are sometimes used for year-round energy estimations. So, because outdoor climate is continuously changing, so transmission load is also continuously changing. So, for estimating the transmission load, the hourly readings are required. So that is DBT, or then solar temperature, wind velocities. So these are the conditions required for calculating the transmission load. So accordingly, the transmission load varies throughout the year, and for calculating the energy estimations, so it is necessary to it is necessary to have such kind of data. That is outdoor data. It's necessary. Outdoor climate has a significant influence on the selection of an air conditioning system and its component. Basically, air-cooled condensers, then cooling towers. So these are the components which highly influence under the outdoor conditions. So while designing such components, outdoor climate has a significant influence. So these are some usage of outdoor weather data, which is available in most of the design data book, city-wise or region-wise. Outdoor weather characteristics and their influences. There are many elements that make up both the weather and climate of geographical location. Most significant of these elements are, almost there are five weather characteristics, mainly the temperature. It also varies with altitude and latitude because generally at the high altitude the temperature is low. Low altitude, sea level, the temperature is comparatively warm. Also, it varies from region, that is from the equator So desert countries temperature is high, and rather than hilly area the temperature is less. So depending upon the weather conditions or depending upon the region, the temperature also varies. Atmospheric pressure is the second important characteristic of weather. It also varies from place to place. Generally, it increases with increasing altitude. Then wind, prevailing and local winds are not spread evenly across the earth. It also varies from place to place, which means that wind speeds also differ by region. In addition, wind speed also increases with altitude as well. So at high altitude, wind speed is comparatively high. Solar irradiance, it is nothing but the power per unit area received from the sun in the form of electromagnetic radiation. Uh, Irradiance in space is a function of distance from the sun, then the solar cycle and cross cycle changes. Irradiance on the Earth's surface additionally dependent on the tilt of the measuring surface, the height of the sun above the horizon, and the atmospheric conditions. So solar irradiance also depends on the latitude. At equatorial, it is the maximum solar radiation it receives, and as the distance increases, the solar radiation decreases. So again, the altitude or latitude mainly decides the intensity of solar irradiance, which is generally required to calculate the transmission load. Uh, then humidity factor, while humidity itself is a climatic variable, it also overpowers other climatic variables, but the humidity is affected by winds and by rainfall as well. So during in rainy season, humidity is very high. Uh, Again, it varies from season to season also, and also it varies from place to place. In coastal area, humidity is high. In desert area, humidity is low. So it is also a one characteristic of weather. Because generally, with the help of humidity and temperature, we define the climate. That is whether it is dry or cold, dry, or hot or dry, hot and humid, then cold and dry, cold and humid. So such kind of climate we generally express with the help of temperature and humidity. Then precipitation is any product of condensation of atmospheric water vapor that falls under gravity from clouds. It affects on humidity because precipitation means the rainfall. Again, it is a seasonal, mainly if the because of the low pressure zones, there is a waterfall or the rainfall happens. That is nothing but the condensation of atmospheric water vapor that is falls from the cloud. But depending upon the precipitation, some locations there is snowfall takes place, some location rainfall, but it largely affects on the humidity of the air. During rainy season, generally humidity is high. Topography is nothing but it is a to determine the position of any feature or location. More generally, any point in terms of both horizontal coordinate systems such as latitude, longitude, and altitude. So mainly that part is there. So any area which is mainly defined with the help of this topography positions like latitude, longitude, and altitude. This has a considerable effect on weather data or weather characteristics. So these are the 7 weather characteristics, and their influences on the outdoor data is considerable. So mostly all these parameters affect on the outdoor data, and accordingly, that's why the region-wise the outdoor data is different because of these 7 parameters. So with this, we have completed this particular topic. And at the end of this particular topic, you should be able to explain the various indoor air contaminants present in the air and their causes, then requirement of outdoor air for occupants, then usage of outdoor weather data in the design, uh, and the lastly, what are the weather characteristics and their influence on the. So this is a more theoretical unit. No concept is associated with this particular topic. You just go through these contaminants. Even by heart, you have to remember some air contaminants and their effects, their causes, and their sources. So these are the factors you have to remember. I hope I have cleared the concept of this particular topic. Thank you very much.